is the last video, Unit 4 review. Antiderivatives, remember, are basically, if we're kind of doing that's what it sounds like, the opposite of derivative, you always write plus c to account for the constants that disappear when you take the derivative. Remember, derivative of constant is 0. So if we're doing the opposite of that, how would we account for something that doesn't exist? You just write plus c. May or may not exist is really what I should say. When we're doing the area under the curve, we can use rectangles to determine it. And remember, this is a helpful table. We can go by the left or right corner of the rectangles. So that means we do the left, it's like that. See, it's left, left, etc. Right, obviously the opposite. If we use the left and it's increasing, it's underestimation. Right, increasing, overestimation. Left, decreasing, overestimation. Right, decreasing, underestimation. It's a good thing to know. Raman sums. Remember, Raman sums are basically just telling us if the number of rectangles approaches infinity, we should get the exact area. This is how we write it. This is like our counter. And xi equals a plus I delta x. So these are the same thing. They'll be the same value. A is the start of the interval, B is the end of the interval, so A is going to be whatever we start at. Change in x is B minus A over N. How many rectangles do we have? And then B minus A. If you're trying to find the left and right areas under the curve, for left, you always start at the first. For the right, you always start at the second. All right, net area versus total area. Net area this is kind of like displacement and distance traveled. Here, net area 0, total area 4. So if we go under, it subtracts for net area, but not for total area. Integrals, basics. Remember the integral is always going to be like this. These two things are always going to be there like that. This is the interval. Sometimes there isn't an interval. That will determine if it's indefinite or definite. No interval, indefinite. Interval, definite. So there might not always be numbers on bottom or top. There are no numbers on the bottom or top. That's when you need to use plus C. If there are numbers, you don't need to use plus C because you can actually figure it out by doing antiderivative B, where you plug in B to it, minus the antiderivative A. That is known as fundamental theorem of calculus part 2. We already talked about the derivative or integral rules, so please review that if you don't know. Fundamental theorem of calculus part 1. That is what we use to determine that we do the derivative of the antiderivative, we get the original function back. And that's the thing where there's a dummy variable, remember, and you basically I have a video on that already, so I would urge you to watch that if you don't understand, but you just have to use, we can use U, plug something in, and we're able to figure out if this is true. That's what the fundamental theorem of calculus part 1 is. Another thing that I forgot to mention, fundamental theorem of calculus part 2, remember I said that's where you can use the intervals on top and bottom of the integral symbol to determine the answer. That only works if it's continuous. All right. What if we want to write something as a single integral? So let's say, well, actually, I'll put it like this. So if we have something like this, if you make it negative, it flips them. And you can add and subtract integrals based on their signs. So this is what I mean by that. If you had something like this, remember this is going from -2 to 2. It's going from 2 to 5. So that means we can write this as a single integral like this, -2 to 5. Last concept, U substitution. U substitution is where when you try to find the integral, you're not able to using any of the rules. You can't change anything to make it easier. Maybe you have two things multiplied. And what you do is you find a value u that when you take the derivative of it, if you put that by something else, it will cancel it out. Um, and the way you always do that is you write this. So you take the derivative of whatever u is, you put it like this. Then you solve for dx, and then it ends up being du divided by u prime. And then hopefully that u prime cancel out whatever you had in the original thing so that you now can do the integral. That's the point of it. Sometimes you have to do multiple tries. There's not really a rule of thumb, but you'll just have to think in your brain, whatever you choose u of, the derivative of it should cancel out the thing, something in there so that you can figure it out. Usually you'll set u to be something that's in parentheses, square root, or an exponent. That's often what it is. All right, well, that's the end of this video. Last of the 5 reviews. I know these were very brief, but that actually does really just cover everything. And if you have any questions, please feel free to comment. But the next video that I'll make soon will be where I go over a practice exam. I will have to make the video unlisted for potential, copyright issues. But if you would like the link to that, please check in the playlists. And there you go. Thanks for watching.